And here we go. Right. This is straight from the book, nice and straightforward. I think you guys may have seen this a little bit before, but it certainly shouldn't be something that you should find terribly difficult. It's a nice and straightforward unit. We're talking about this thing called cumulative frequency. Cumulative means accumulative. It just means increasing frequency, really. That's all it is. Real simple. Let's see if I can get this working. Right. It's all about representing data and different ways that you can represent data and different ways that you can look at the data that you have and draw information from it. So for example, two starters right here, I've got the working out the estimate for the median set of each data. Remember the median being the middle. Correct. Right, so let's have a look. Goals 0, 1, 2, 3, 4, and the frequency. Now, just looking at that without working out anything, which one do you think it would be in the middle? I think it would be 2. I'm not sure, but I think it looks to be about 2 because 8 and 18 and 30 and 6 and 4. Maybe it'd be 1 or 2. And then the hand span 10 to 12. The one in the middle maybe 14 to 16. I'm not sure, but what we can do is we can do this cumulative frequency. So it starts with 8, then to 26, because 8 plus 18 is 26, plus 13 is 39, etc. Okay, so we get to all the way up to 49 games with different numbers of goals. And what we need to do is work out the middle number. So 49 divided by 2 is 50 divided by 2 is 25, and you can see that is in the goal section, in number of 1 goal there. Handspan, the quantity, again, we've got that cumulative frequency going along, 12, 30, 53, 73, and 80. We do 80 plus 1 divided by 2, which is 81 divided by 2, which is 40.5, I think. But I can easily see that the 40.5 piece of data will be in that range there, 14 to 16. Okay, so this is something that we've done definitely before, but what about if we want to represent it on a graph? Okay, so let's look at this right here. We've got some temperature, and these are different days, and these are the number of days that we had from of temperature of 50 to 60 Fahrenheit, 60 to 70 Fahrenheit, 70 to 80 Fahrenheit, etc. Now, the cumulative frequency is just adding them up as you go along. Okay, that's all it is. So 200 days, that's the cumulative frequency. So how are we going to plot this? Okay, we can draw a curve. We've got our cumulative frequency. It always starts at 0. Right, the left-hand side is your cumulative frequency, the number of pieces of data. It always has to start at 0 because, by definition, that's where you start. Now, the right-hand, the bottom axis, that doesn't have to start at 0. It can do if you want. It can start at, for example, here I've got starting at 40. It could start at 50 as well. That doesn't matter as long as you're able to plot your piece of information. And then all we do is just plot those bits of data. We start with the lowest. Always have to start with the lowest, and that goes right there because that's at 50 and that's at 0. So if you think about it, there are no pieces of data at 50 or just below 50 degrees Fahrenheit. There are 0. So it's got to start from there. Okay, well, what are we going to use next? Now, it goes up to 60. Yeah. Between 50 and 60, there are 17 pieces of data that we don't know exactly what it is, but we need to take the next next limit. So here the next limit is 60, and we know that by 60 degrees Fahrenheit there have been 17 pieces of data. Okay, and then we do the same thing for 70 degrees, 63, 80 degrees, 136. 90 degrees, 188, and 90 plus 90 to plus 90 is to be 200. up to the 200 mark. So this is not quite yet a curve because we need to draw a curve. It cannot be a straight line. It's got to be a curve. That's one of the non-negotiables, I'm afraid. But you can see that this curve represents all of that data, and we can make an estimate. We can make an estimate for all of our different pieces of data. So, for example, estimate the number of days with a temperature below 75 degrees. Well, where 75 is there, okay? And then if I draw a line up to the graph, we get that, and then to the left, we get this number here, which is something less than 100, more than 90, maybe something like about 95 days. So this is how you can estimate a number of certain days with a given criteria. Okay. So what about something like this? This is just another very, very simple, straightforward example. We've got our marks of a test, 0 to 19, 7 people got that, 20 to 39, 24 people got that, etc., etc. Our running total, our cumulative frequency is 7, 31, 41, 166, and 200. Okay, and then an example question might be estimate the number of students who achieved more than 65 marks. Okay, so we're going to be looking around about this area here, but we don't know exactly how many students got more than 65 marks, because we know that 52 people got between 60 and 79, and you could say that 52 and 34, that's 86. That's the number of people that we estimate of 60 or more, but what about 65? We just simply don't know, because all of those 52 marks, those 52 pieces of data, they could all be 61 marks out of 100. We simply don't know. So we're going to have to do this cumulative frequency graph and see what happens. Okay, so again, cumulative frequency always on the left, and then your other thing that you're measuring on the bottom. And here we're starting from the lowest mark, which is 0, and we're going to go 0, 0, because at 0 marks there are 0 pieces of data. We've got to start from somewhere. We've got to start from 0, and then we always go to the upper boundary. So 20 would be 7. We know that by the 20th by the 20th mark, 7 people will have gotten their scores in that area. And then we carry on plotting all of the rest up to the top. Now, it's really important that also this here has to finish at the top of both of the scales of our data. Most importantly, it has to finish at the top of the cumulative frequency. So if we've got 200 people, it's got to finish at 200 as well. We draw in our curve, and you can see it's just slightly different shaped to the other one that we had, but nevertheless, it's still just a regular cumulative frequency curve. And the question was, estimate this number of students who achieved more than 65 marks. Well, we find 65 on marks, draw a line up, draw a line left, and we get maybe 125. Is that right? But what do also we want to do? The number of people is not going to be, okay, 123. This is where we've got to just, I said, be careful, because if we get 123, a lot of people will put down 123, but that would be the number of people who got less than 65 marks. Yeah. So we want number of people more than 65 marks, so it's going to be the total minus 123, which is 77 students. All right. So, for example, this one right here. No, I don't. Oops. Now I'm gonna have a go at writing this with my fingers, but here I'm going to have my cumulative frequency 8. 12 gives me 20. Oh dear, it's a bit big. 20. Oh, I'm going to write these in, I think. 8. Ooh. Here we go. Okay, 20, 66, 101, 120. And again, what I'm going to do is I will actually draw this one though. I'm going to draw my cumulative frequency graph. I'm going to start at 0. start 0, and up to 20 marks, I'm going to get 8. So that's going to be my first swap right there. Then 40, I'm going to mark it at 20. Oh, it appears to have disappeared. Never mind. Well, I'll do it the old-fashioned way and click next. So we're just plotting our points. We're trying to plot our points. There we go. 20 is 8, and then 40 is 66. So 40 is going to be 20, and then at 60 it's going to be 66. At 80 is going to be 101, and at 100 is going to be 120. It's always really important to just check our running total and double check that with the number of people who did the actual test. Usually they give you that piece of information, and then we do that. Now the question is, 3/4 of the people pass the test. Okay, and this is actually used quite often by teachers, and especially when they're doing exams and they are calculating who gets what grade. Edexcel, they do this every single time when they're organizing grade boundaries. It's very interesting. So how do we do 75%? So 3/4 of people pass the test. So, well, 3/4 of 120 might be 90. So the 90, 3/4 of the people pass the test. It means 1/4 of the people fail. So we use this thing called the lower quartile to work this out. It's it sounds more difficult than it actually is. The lower quartile is just the 1/4 way through our cumulative frequency. So 1/4 of your total number is 30, and the lower quartile mark is going to be 46, I think it is. So that means that the pass mark should be 46. Okay, because 3/4 of students are above that mark. You also have things called the upper quartile, which I will discuss in another video almost immediately. Right, let's see if I can actually. Yes, here we go. Okay, so we've got, carrying on the same stuff, we've got the median, which is the middle. And we can estimate that from the cumulative frequency curve, absolutely no problem. The median will be the 100th piece of information. So that's not always going to be the 100th piece of information. It depends on how many pieces of data you actually have, but it's just take the whole total and halve it. So our 100th piece of data is roughly 75, 76, something like that. Again, this is an estimate because that cumulative frequency graph, that curve, is just a guess. We don't know if it's actually accurate. This is just an estimate. So that's our median. The quartiles, we say they're the lower and upper quartiles, and we also have a thing called an interquartile range, which is just the range, the difference between the lower and upper quartile. But nevertheless, it's 1/4 of the way and 3/4 of the way through the data. So the lower quartile here will be at the 50th value, which we can estimate to be about 67. And the upper quartile is the 150th piece of data, which is 83, something like that. Okay, the interquartile range is just the range between the upper quartile and the lower quartile. So yeah, upper quartile minus lower quartile will give us our answer. So that gives us 16. These different values, they tell us a lot about the spread of the data. So if a cumulative frequency curve is very, very steep and the lower quartile, interquartile range is very, very small, then that means all the pieces of data are grouped very, very closely towards the center, and there should be. Has the camera gone off? Has the camera gone off? I don't know. And so all the data is squashed, and all all the pieces of data are around about the middle of all the things that we've measured. Okay, so oh, done this bit. Now, the other thing that we sometimes get asked to do, well, sometimes all the time, is to calculate the value of a something's percentile. So, for example, the 20th percentile, it sounds harder than it is. It's just the value which has 20% of the data before it. So, for example, here, I look at my 20th percent. Now, because there are 200 people, that means the 40th piece of data. I want to know how many marks that is. So that should be about 42 marks. So 42 marks is my guess that 20% of all of my data is below. Okay, 60th percentile, again, you have to look at your cumulative frequency, your totals. 60% of 200 is 120, so I look at that, and 60% of all of my data should be below that mark, which is about 62. So 60% of all of the pieces of data are below 62 marks. Okay, calculate this into percentile range, nice and easy. Yep, just the difference between the two. So this is the stuff from the book, which it's not super invigorating, if I'm honest. It's just one of those things that you just got to have a little bit of practice at getting done and getting good at. You don't really see it much again for the entire GCSE course. You start using it again when we get to A levels, but once you've got this, it's also, I mean, realistically, it's also about you're looking at about 10 marks, 8 marks to 10 marks in the GCSE, just because you're able to do this, which is a great thing to have. So yeah, have fun practicing this. I've also put another challenge for you. So if you've done this before or you find this very, very easy, then have a look at the challenge, because I guarantee that is much, 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 much more challenging. Right. See you guys later. Bye.